Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind, doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV, or Wednesday Experimenters Group Night. And Justin, VK7 Tango Whiskey, at the microphone. So before we get underway, wish to acknowledge Tasmanian Aboriginal people as the traditional owners of the land upon which we're presenting tonight, and pay my respects to elders past and present, for they hold the memories, the knowledge, the culture and hopes of Aboriginal Tasmania. So we've got a little bit of a continuation of last week, and I'll do a quick transition. We've got our Kia theme. That's enough. That's all you get. We've got a little bit on a new Kia. Well, a new old Kia. I'll have to say it's a new old Kia, and there's a bit of a story that goes with it, so which we'll get to. And in building this particular Kia kit, I went down a rabbit hole of a thing called WinKeyer. And whenever I look at a Kia, they all have a WinKeyer emulation mode, or they follow the WinKeyer standard. Standards are so good. There's so many of them. You just find the one that suits. I joke. But lots of them have WinKeyer emulation. And so I went down the rabbit hole of WinKeyer and what that actually meant. And then I noticed that the K3NG and a few of the other Kias that are out there have CW decoder functionality. And I then went down the rabbit hole of how do they do, and what are the algorithms that they use to do the decoder, and what are the most popular ones. And so there's a little bit around that. And if we have enough time, we will eventually get to DUBUS magazine. There's some fascinating articles in there. So anyway, that's the next, hopefully the next less than an hour. And just to say hello, we've got Steph, VK5FQ, who is also going out on DVB-T 445.5 megs in South Australia. So hello, Steph, and hello to our VK5 viewers. We've got Peter, VK3MV. Hello, Peter. John Hall, VK7JDH. We've got John, VK7MUD up in Queensland. Darren, Mount Isa, VK4GEO. We've got Bruce. Hello, Bruce. VK7SKY, Sky, great call sign. And Stephen, VK3 TTF, who I have been going backwards and forwards on Discord over today. So yeah, that's... and we've got Mark, VK7FMAC. Hello, Mark, down at Dodgers. So... fantastic. And if there's any questions as we go through, please drop them in the chat, and I'll try and get to them. And I apologise. Last week, I noticed that there were some comments in the chat around the microphone and having a second person in the studio. So I didn't actually see them on the way through. Oh, and Richard, VK7ZBX, our EME guru there in Tea Tree, sunny Tea Tree. So fantastic. Welcome, Richard. So, without further ado, what I will do here is the content in the studio. Now, on not last weekend, but the weekend before, we had a bit of an expose last week on our car boot sale. Now, at our car boot sale, there was a whole bunch of deceased estates, and one of those deceased estates was VK7TL, Tom Masher. And in going through a couple of boxes of items that were there, I came across a little kit. And that particular kit, that particular kit, if I go here, that particular kit had a K1EL Keyer K14 Keyer Kit. Now, it was a very simple little kit, and I looked it up, and I couldn't find very much about the K14, but I could find a whole lot of stuff around the K16. So one of the things I went to was hamcrafters2.com. And on the hamcrafters2.com, there is a whole bunch of keyers, absolutely a whole bunch of keyers, all doing different things. There is the WinKeyer, and we'll go into that in a sec. And if I scroll down, there is the K16 external. So this is external battery, Keyer board. Now, this is the equivalent, this is the surface mount equivalent of the K14 kit that I actually then built. So, without further ado, if I take the top off of our little Keyer here, I'll show you what's in the box. Now, surprise, surprise, this looks very similar, absolutely very similar to our K16, which you'll see on the screen. So, this is the earlier version K14. It's got a little PIC chip on it. The amount of functionality that they have programmed into the PIC chip is phenomenal, and I'll show you that in a sec. It has a built-in speaker on here, which I'm not using because it's pretty quiet. This also has the 3-pin regulator on it, so that you can actually run it from anything above about 8 volts, and it brings it down to 5 volts and powers the PIC chip. But what I'm actually using is an 18650 battery, so 4.2 volts, 18650 battery that's powering it. It'll power from anything from 3.3 volts up to the 5 volts, and then the regulator obviously needs to be used. There's some keying transistors for the transmitter. There's a whole lot of connections for your paddle, etc., etc., and there's a whole lot of connections for the memory keys, and I'll go into them shortly. Now, one of the things I did, and this is after reading about the little kit, is I put an extra transistor and put a bigger speaker on here to make it a little bit louder, because it was quite quiet when it came through that little PCB mounted speaker. And I've put it all in a box that also came from the deceased estate of Tom VK7TL. So it's a VK7TL production. And you can see there's a potentiometer, which is speed. I'll demonstrate that in a minute. I've got some holes for the speaker. The key, the transmitter out. So this is an active low, so it grounds the push to talk button, or the way that you actually key the transmitter. There are four push buttons, an on-off switch. The four push buttons give you combinations, and I'll show you that in a minute. It's quite smart the way that they get a whole lot more functionality out of the four buttons. And there is a really nice function on this keyer, and I'll demonstrate that in a sec. But anyway, put it together. I've got it sitting here. I've got the TP3 back in the studio, the TP3 keyer on a decent piece of steel, so it's not going to move around. Demo the unit, turn it on. It does a little dot, a little R saying it's ready. In its current mode, it's in the operational mode. So it is literally what you're keying at the speed that you're keying. Now I'll bring this over to the speaker so that you can actually hear this a little bit better. So that looks as if it's reasonably high in level. Just let me know if it's not. I'll go back to my screen so that I can see. Okay. So one of the things that you can do with the keyer is obviously the speed. Now that's on the potentiometer. I'll just keep it going and give you an idea of the speed that you can vary it to. So quite slow, a bit too slow. That gives you the speed pot. You can also do it through commands. And one of the, as I mentioned, the really nice things is you can program up the memory keys, these message keys, and you'll notice this is a command and message key. This, if you push it for about 2 seconds, it goes into it gives you a little R. So it's ready for a command. The command comes in through the key. If you then push this for 2 seconds and it gives you a ready, and you push one of these memory keys, and it can be this one as well. If you push one of these memory keys, it will then remember what you've actually keyed in. Now I've set these up, a couple of these up already. There is my call sign. So if I push the yellow one, and the really nice thing about this keyer, one of the other nice things about this keyer is it plays it at the speed that you've currently got it set to. So if I start playing this, I can actually speed it up. So I've sped it up, and if I push the yellow button, it's playing it at the speed that I've actually set it at. So on the yellow key, I've got my call sign. I've got a CQ on the black key. And then on message 4, I just put a DE. So on a sequence, on a normal calling sequence, you'd go CQ, D, call sign. Now, the really, really nice thing about this keyer is you can queue button pushes. So if I want to go CQ, D, VK7TW, all I need to do is go and it has literally played out the button pushes without me doing anything other than push 3 buttons in sequence. So I really not like that feature, because you can literally, if I wanted to say do 3 CQs, I push it 3 times and it automatically plays out 3 CQs. So, and I don't need to push it again. I just push it and it'll play them in sequence at the speed that it's set to. So really, really nice feature. And you can set any of these to whatever you like. There is actually there's 6 messages that you can store. What you then do is, to get 5 and 6, is instead of pushing 1 button, you push 2. So that gives you 5. That gives you 5, and that gives you 6. And in the same way, you can push those 2 and get, if you've programmed in a 6th message, you can then play out the 6th message by just pushing both buttons at the same time. So really, really nice feature of this particular keyer. And it comes out of the speaker. There is a jumper on the board where you can disconnect the speaker or connect the speaker, and you could bring that switch out to the front panel if you wanted to. But I'm primarily using it as a bit of a practice keyer, a practice oscillator, I suppose you'd say. But really, really like the arrangement they've done here. So some of the other messages and some of the other functionality that you can operate with, and there is the K14. So this particular keyer has a fantastic instruction book of 33 pages. So it gives you all of the functionality that is available on the K14 keyer. There is supply voltage monitoring. There is dual user configuration, so you can set it up for you or set it up for somebody else. There is multiple transmitter outputs, so you can go out to multiple transmitters. As well as the messages, you can store your call signs and recall that at will. There are dual message banks, so you can actually have 12 instead of 6. You can actually have 12. You can change the message bank from one to another. Fast message interruption. That's the other one. You can change the side tone frequency. Now let's do a live demonstration. Now I probably just jinxed this. The side tone frequency is Z. So push the command. Oh, Z. Da da di dit. Let's try that again. This is push the dits and it goes down, push the dars and it goes up. And you find where you want it, and then you push the message one again. So you can change the side tone. There is message stacking. You can get up to 10 messages. So this is what I'm talking about with multiple button pushes. You can have up to 10 pushes, and it will remember the 10 of them and play them out in sequence. There is a beacon mode, so you can actually put the board into a beacon mode. So if you've got it working as a beacon, it can give you the CW that you program in as part of the message. There is push to talk lead in and tail settings. So if your transmitters is slow to switch on, switch off, all that sort of stuff, you can build that into the keyer. Tuning duty cycle, so the dits and the dars, the key down, key up, it defaults to 50%. But you can change that. There's a keyer lock, so you can lock it out. Fixed speed settings, the speed pot range you can change. You can have a paddle serial number decrement. So if you're in a contest and you're wanting to automatically increase or decrease, I suppose. I've never been in a contest where it decreases, but if you wanted to increase your serial number, you can get it to automatically do that and send out the next number in the sequence. So really, really nice. Command response time, so it's currently set to about 2 seconds. You can shorten that. And full-time speed pot, so you can you can switch that on and off. So there is a remarkable amount of functionality that is incorporated into the Keyer, and I can only say the K16. This is the K14. The K16 must be have a whole bunch more functionality, and this is, surprise, surprise, it follows the WinKeyer standard. So that's message functionality, and fantastic manual to come with it. The cheat sheet. So just to give you an idea of how much functionality is in here, if we go to the document camera, these are intermediate command lists, the extended command list, and the embedded message command list. This is all built into the K14 as the functionality that you get in the K14. So just off the show, absolutely off the show. And this little kit, I think this was about $20 US, and it was a while ago. The K16 is about, it's not that much more than that. The shipping will probably kill you, but just phenomenal. So anyway, I'll stop banging on about it. It is the K1EL Keyer Kit, and this is it built into a box, and fantastic. Really love it. So yeah, I just off the show. I have a Mark 1 straight key and a Mark 1 brain to do all the settings. Oh, very good, Peter. I love it. Absolutely love it. And also hello to we got Bronson and we've got David VK2ZRH. So Mark 1. Now the other thing, actually, I forgot to mention, you can have a straight key with it. You can absolutely have a straight key with it, and so you can use the memory functionality with it. Along with a straight key. So there is a straight key mode that you can put it in, and it works a treat. So the Keyer is not only paddles, it is straight key as well. So there you go. Now I mentioned WinKeyer. Now when I started looking up, I did go down this rabbit hole today. WinKeyer functionality. So and the interesting thing is, it's K1EL who came up with the concept of WinKeyer. So the WinKeyer was when you had originally, and we're probably talking, I don't know, 20 odd years ago, where you could have the start of a computer connected to a radio, and there were timing problems. A lot of people experienced timing problems with the code, the Morse code, being generated by the PC and then being sent via serial line or push-to-talk line or some other interface to the transmitter. So what they ended up coming up with was a WinKeyer hardware. Now, back at 20 years ago, it was probably, I'm not sure it would have been microcontroller. It may have been, but it was probably TTL type logic, TTL or CMOS type logic, that they generated the dots and dashes, and that what they ended up doing was bringing that out off the PC into its own hardware. You didn't have the problems of timing. You didn't have the problems. It was all independently generated. Now, then they had to come up with some functionality around that Keyer, and it was K1EL who came up with, I think, the WinKeyer standard. So this was the standard functionality that you would find in a WinKeyer standard box that would sit between your PC and your transmitter. The WinKeyer had some standard stuff around contests so that it was sending some information to the PC for the contest side of it, so serial numbers and all sorts of things, and it was also then obviously keying out the contact sequence that you were wanting for the contest. So there was this WinKeyer functionality that was built up. Now there is and I'll actually put a link to this particular document, because there was a great little document around WinKeyer, a low-cost, fully featured Morse code keyer capable of fully controlled through a USB interface. It enables software developers to create a fully integrated Morse keyer within the program. So this was, okay, move forward, more functionality, more powerful PCs. You could bring that functionality into the PC, and then be able to operate everything from the PC. So you were able to generate the Morse code through the keyboard. Hold that thought, because in 2 weeks' time we'll actually I'll show you the K3NG keyboard driven, and so this goes through a little bit of history around this, and you can see 2016 is the date on that particular document. So the WinKeyer functionality that you end up with, and the standard WinKeyer functionality that most programs then implement, is now let me go to the document camera. This is now, there's obviously CW sending, of course. There's a pause, there's a key down, so for transmitter tuning and all sorts of stuff. Unbuffered and buffered speed settings, iambic A and iambic B and bug mode settings, automatic, so this is in normal DIT priority or DAR priority modes. You've got the Farnsworth, so this is the spacing between the letters, so a great learning arrangement is you put the speed of the characters at the speed that you want to learn at, say 20 words per minute, and then you use Farnsworth spacing, which puts the spaces in between, which makes it about 10 words a minute. So it gives you a little bit of time in between characters just to realize what the character is. There's pointer operations, you can backspace, there's side tone frequency settings, you can reverse the paddle if you're used to it doing a different way. There is a dead man's handle or a watchdog paddle watchdog timer, keying compensation, etc. Push to talk, tail and lead times, speed settings, etc., all the way down. So this is pretty standard. This is the standard that WinKeyer came up with. And you'll notice down here I've put here WinKeyer compatible keyers work with the N1MM and the N1MM Plus, so the DOS and the Windows versions of that particular logging software, and it works without having to do anything. So WinKeyer, you'll see if you've got a keyer, it will probably be WinKeyer compatible, and that's the reason why it follows that particular standard and gives you that functionality if you're wanting to operate CW in a contest or just making contacts on CW. So that's WinKeyer. So that was okay, a bit of learning today. Then the next rabbit hole that I happened to go down was, now for our can I just start off here by saying I am not an expert in this by any means. We are talking fast Fourier transforms here. So this is how we break down a particular frequency into its component frequencies, and then it then moves into a digital signal processing world, so enables you to do particular things and filtering and all sorts of things with that particular frequency. Now, there was a very smart guy back in the 1950s called Gerald Goertzel. Gerald Goertzel. Now, let me go to studio content. Now, I'm on Wikipedia. This is, and he came up with, and we're talking about the 1950s here, so this would have been all hand calculated, or maybe early computing calculated. but is a digital signal processing technique for the efficient evaluation of the individual terms of a discrete Fourier transform. So what that, just decode that for me. What that means is you can put a frequency in, or a signal, a signal is, that's a better way of putting it, an actual signal into this particular, and put it through this algorithm. And what it does is, if you want to listen for a particular frequency, so if you've got a whole bunch of noise which has got some signal in it, and you want to hear the CW signal, which is around about 580 hertz, what you can do is tune this algorithm to listen for 580 hertz. Now, our ear automatically does that. So our little Goertzel processor in our brain can differentiate that 580 hertz and home in on just that particular frequency. And most of what you hear is a whole bunch of frequencies and all the mixing products from those frequencies, and you end up with a noise or a tone or a particular note. What Goertzel had came up with was a really, really efficient algorithm, which is now to a level where you can put it into an Arduino or a Raspberry Pi or a small microcontroller, and enables you to actually differentiate the different frequencies that you're hearing. So for a CW, for receiving CW, what it can do is differentiate the CW signal from all the other noise that's on that particular part of the passband. So really, really handy. And what a very smart guy in Sweden, I think that's Sweden, OZ1, I think that's Sweden, has been able to do is put this into a CW decoder and use this particular algorithm. And hang on, you can, and I'll put all the links into the video description for this. But you can see OZ1JHM, who is Hjalmar Hansen, and he's got a great little website which has a little YouTube video of him actually receiving this. Now I don't know whether this is going to echo or not. I just have to mute. I just have to mute me. Okay, that's good.
I'll try to program so you do not need to be so good in CW. I mean, the sending CW would not have to be so good, but of course, if it is very off the 137 baud, you know, it will always be hard to copy.
So it's absolutely, and I'll put a link. I will put a link in the video description to that particular website, because what he's actually done is, and this is a little Arduino, Arduino Mega. So we're not talking very, you know, a really powerful, really powerful computer here. But he's implemented the Goertzel algorithm. A great little, fantastically simple little interface, and you can see here. This is the Arduino Mega. I'll just scroll up a little bit because you can see the Arduino. Sorry, Uno. Sorry, no, it's not even a Mega, so it's even a less powerful processor. He's got a little 2-line display, LCD display, LED there. And this, I love this. This is the interface he uses. What he's got is two 10k ohm resistors into two analog inputs, and he's got one at 5 volts and then one at ground. So what you've got in the middle of here is 2.5 volts, and there is and then a bit of AC coupling in here with a capacitor to the speaker. So whatever you're hearing, and that could also be a speaker used as a microphone. But what he's that's the audio interface into his Uno, and a fantastic little bit of software that then listens using the Goertzel algorithm and decodes the CW as it comes out, and it auto adjusts for speed, so it only needs to hear a couple of characters and it works out what speed it's happening at and then decodes accordingly. So there's some smarts built into the software, but I'll put the link to that particular article. What I'm looking to do is build one of these and find it out, because this particular Goertzel code has been built into the K3NG Keyer. So the Keyer I showed you last week, it's actually built into that. You can switch it on, put the libraries in there, and then recompile. So I'll see whether I can in the next 2 weeks actually put that little interface together and see whether we can put it into decoding mode and see if we can also get not only a CW encoder but a CW decoder. So we'll see how we go. We'll see how we go. But the Goertzel algorithm, so it gives you a specific frequency for a range of frequencies that go in there, and it enables you to then listen for that CW signal in all that noise. So there you go. Now, how are we going for time? Oh, okay. We might get to DUBUS as well. So DUBUS magazine. Now let me move and not bang this down. Oh, sorry about that. That was right next to the microphone. So everyone just woke up. So apologies for that. It is quite a large piece of steel. So DUBUS magazine. Now, for those who don't know, DUBUS magazine, if you're into VHF and above, into microwaves, this is currently the only magazine that focuses on this particular frequency range. So the high into microwave frequency. It is a dual language magazine, so everything is in English and German, and produced by a German guy in. Now let me find who it actually is. Let me go to the editorial because I should know this. I absolutely should know this. The call sign of the guy. No, I'll find it. I'll find it as we go through. Oh yes. Joachim, DL8HCZ, or he's also CT1HZE. So who's the editor and heads up the DUBUS team. So fantastic quarterly magazine, and some fantastic, very hands-on, but also there's a bit of a balance with theory and also hands-on in the magazine. So let's go straight into it. Front cover is now Charlie Suckling, who is known to us. DL3WDG has some great designs. Rex has worked with Charlie for some of his EME and also some of his amplifier designs. He is a RF engineer and RF designer. So the very first one here. That's a GaN device, so a gallium arsenide device, phenomenal devices, and you can see the simple matching arrangement here. There's a couple of capacitors here, a couple of capacitors. There might be something there, an inductor across to a network, and then the device sitting in the middle, and just phenomenal. And this gives you 200 watts, 200 watts on 23 centimeters. That's on a pretty decent, decent heat sink to get rid of the heat from the GaN device. But this is a full construction article, so it's telling you how to put it together and then how to test it and what you can expect out of it. And then you can see here, so this is the English article that's got the pictures, and then we go into the German article that hasn't got the pictures, but it has the notes to tell you those pictures. Almost 30 years of VE7 BQH antenna tables. So this is long-standing the Yagi antenna tables, mostly Yagi, but there are other antennas. But these are the tables that we used to use. 1987, there you go, DUBUS in 1987, 1996. So updates. GG7YBN will be known to quite a few people, probably using their Yagi designs all over the place. And again, we go into the German. And now this is a German article. Let's go. Oh, now deep into the technical. So image rejection improvements and LO, so local oscillator nulling on IQ mixers. Now, Louis Cupido, very regular contributor to DUBUS magazine, and he talks about image rejection on IQ mixers. So how you do it, deep into the mathematics and how it's applied, and then into the network design, and then the improvements on the network design, LO leakage, etc., etc. You don't want LO leakage, absolutely. You don't want it being an LO contact, not the frequency you're trying to make the contact on, and not the LO. Now, tiny PLLs. By Daniel Upstrom, SM6VFZ, locks without a PLL chip. So this is again a tiny PLL, a phase lock loop, which enables you to lock your the frequencies in your transmitter and receiver. Minuscule, little USB-C connector, that's a match. So it's less than a match, about a half size of a match, and absolutely off the show, and multiple frequencies, output frequencies, so you can lock the various frequencies that you need to lock inside your transceiver, so that you can operate the narrow bandwidth weak signal modes. Now, article 47 gigs EME setup. Now this is off the show. This is EME with a decent amount of power for Earth, Moon, Earth. Now the thing I'll point out here is, have a look at the precision here. We've got a vernier caliper type adjustment of particular. Now 47 gigs. That's off the show. Wavelength 6 millimeters at 47 gigs. No. So the required precision is 1/10 of a wavelength, and the wavelength is 6 millimeters at 47 gigs. So you need 1/10 of 6 millimeters. Oh my God. Okay, and you can see the little horn. That's quite very small. Obviously, we're talking about very small wavelengths. We've got our coax. We've got our waveguide switch here for 47 gigs. Using WR22, so the really small waveguide. The control boards. The control board, the picture of the control board, that's a Arduino Nano, like we're using in the K3NG. Test reports, the results, and yeah, all of the references that he's used for 47 gigs. So absolutely outrageous. 10 gig booster for the IC905 project follow-up. So this is boosting and getting more out of your 10 gig arrangement on your IC905. That's a part 2 of a article, so an earlier one. The Bragg effect. Now the Bragg effect. Look left and look right. The Bragg effect occurs when radio waves encounter moving C waves. Certain Doppler traces can then be detected in the reflected waves, and Niels Schiffer, DK80K, has investigated this fascinating connection between radio waves and C waves in theory and practice. Anyone with an SDR can do the same. So there you go. and where he conducted the. So this is Spain and France, and all the way through to Holland, I think. So yeah. Anyway, absolutely amazing. The Bragg effect. Well, named after one or other of the Braggs, I think, from South Australia. Nobel, the first, I think I'm right here. The first Nobel recipients that were a father and son. They were at Adelaide University, because I attended lectures at Adelaide University in the Bragg Lecture Theatre. So there you go. Now, the last bit of DUBUS is always the contests that have been going on. So it's the results from that contest, and then what's going on around the world, the soapbox, and there it goes all the way around the world. Tropo reports from around the place, from all the way through from 2 meters to 10 gigs. Microwave North America, so what's going on in America at the moment in the microwave space. And then Japan, France. Actually, hang on, there's a call sign. VK9QI, Christmas Island. So the Christmas Island de-expedition. Microwave Spain, Microwave UK, and then advertising for Microwave Italy. And news and comments. So anyway, that's DUBUS magazine. A really quick run through of DUBUS magazine. If you're into microwave and VHF and above experimenting, it's the magazine of choice. So yeah. Now space weather. Nothing remarkable after our big show last week. Nothing remarkable. Everything's settled down. The HF bands are starting to come back. Our total electron content is decreasing, thank goodness, because the lower bands are now starting to come back. So nothing remarkable. Future training. So we've got a foundation training and assessment day on the 21st of February. So if you're wanting to attend that particular day, get in contact with Reg via reast.assessor@gmail.com. Now, next week we have, and we'll be streaming this. So next week we have Roger Harrison, VK2ZRH, who is from the originally from the IPS, the Ionospheric Prediction Service, and now the Space Weather Service of the Bureau of Meteorology. And so Roger's coming along to give us interpretations of ionospheric data for propagation prediction. And so all of those terms that you've looked at and gone, I think I know what that means, but I'm not quite sure what relevance it's got to propagation or whatever. Roger is going to let us know what they're all about and how to then use them to predict some propagation conditions. So that's next week. That's our presentation night, February the 4th. Then February the 11th, so the next Wednesday night, we follow on. And we've got our first forum night for 2026. It is WSPR Propagation and the tools, the WSPR Propagation tools. If you've ever been to the WSPR Net site, which is the site where if you run WSPR and you check the little box that says upload the results to the internet, it all goes to the WSPR Net database, and WSPR Net then you can do some rudimentary presentation on global maps and statistics and signal to noise ratios and all sorts of stuff. But down the left hand side there is a whole list of different tools that people have written to use the WSPR data set. And the very top tool, and I'll shout out to Phil VK7JJ, who I noticed was receiving my 30 metre 10 meg signal quite a bit. And I'm also receiving his, obviously. He has written the very top one, which is WSPR Rocks and I used it. Some of the stuff that I showed last week, I actually used WSPR Rocks to do the global map presentations and a few other things. So Dr. Andrew Klekocuik is going to give us a bit of a talk on WSPR datasets because he's been using it for propagation studies. He's an atmospheric physicist. He's been using the WSPR dataset for some studies he's been doing, and so he's going to talk about how he uses it, how useful it is, and then we'll open it up to everybody to throw in how they use and what they use WSPR for. So, and then the Sunday, so February the 15th. February the 15th is actually our annual general meeting up here. There's a member barbecue after the AGM, so that's February. And if you want to catch up with what's in March and April, etc., have a look at our events page on the reast.asn.au website. So that is now no comments. So that's your blooming lot for this week. We're actually going to finish 10 minutes early, so I love it. Always love finishing 10 minutes early. And we'll see you in a fortnight's time. This is 73 from Justin, and this has been VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night, and we'll catch you in a fortnight's time.